Now I would like to show you a very cool app called the dfield app, which allows you to plot direction fields on a computer. And the way you do it, you go to your favorite web browser and type in dfield app and go to the first result that shows, in this case from the University of Arkansas. And it is a very cool program that helps you plot direction fields. So the previous example that we've done was y prime equals y plus 2. So to use this program, you literally write y prime equals y plus 2, and you just graph it. Ta-da! And that was, in fact, the same thing as the direction field we found before, where it curves upwards exponentially and then downwards. And in fact, the cooler thing is you can even plot or draw sample solutions just by clicking on it. So if you click here, you have a solution, here another one, here another one, and also for solutions going down. And by the way, there will be a programming assignment later where you would have to do this using the computer. And this really works for any kind of ODE. So let's now do the same thing, but in this case with the ODE, y prime equals 4 minus 2y. But the problem is, if you do it like that, it will not run, because if you want to write multiplication, you have to do 2 times y. So don't forget about the star symbol, but same thing as before. It gives you this cool direction field plot, and you can plot this. How cool is that? No more suffering. And of course, there's nothing special but the t dependence. So you can also do y prime equals 2 times y plus 3 times t. So 2y plus 3t, you plot it, and you get some cool solutions here. Again, a really nice way of visualizing this. But of course, nothing stops you from doing nonlinear things as long as it's of the form y prime equals something. In fact, let's do sine of y times cosine of t. Graph this, and you see you get those really cool eye formations as well. And there are a couple of other cool pictures I want to show you from the lecture notes. So you can also plot the direction field of y prime equals t squared over 1 minus y squared. And you get this cool picture like that. And there's also this picture that I found that looks quite freaky. And in fact, what I want to show you is even more cool pictures, because this is one thing that really attracted me to ODEs, no pun intended, because you can draw really cool pictures. So one thing I want to show you is what's called the van der Pol system, which models electric circuits, I believe. And you get this nice picture, which is really cool. And of course, we talked about the pendulum equation from physics, and where the pendulum swings back and forth, and you get those really cool phase portraits, those cool curves where it goes up and down, kind of like cute eyes. Another system that we'll talk about at the end of the course is what's called the predator-prey system, which models the evolution of bunnies and foxes, where, of course, foxes, they eat bunnies, but if there are not enough of them, they will starve. And what's cool is that we get this periodic curves that happen. And then another one that I really like is what's called the Lorentz system, because once upon a time, there was this mathematician called Lorentz, and he was like, I want to predict the weather using differential equations. Well, guess what? He predicted chaos because this is the very first example of a chaotic system, which is really, really cool. And last but not least, this is a cool picture I found about neural networks. I'm not 100% sure what it represents, but it's very neat. And in the next video, I do want to show you more cool animation of ODEs. So stick around.